drawing the three axes, Z, Y, and X, label. A vector is a point in space with magnitude and direction. So, change the color. So I can have a vector here at points 2, 5, and 1. So it's 2 points along the x-axis, 5 points along the y, and 1 along the z. Z being towards you. So I can have another vector. I'll say this is at points 7, 2, and it can also be at 1. So I'm going to call this vector A, and this vector B. So I can add vectors together. This would then create a vector 9, 7, 2, which would be, I don't know, up here. 9, 7, 2, which can also be visualized as going up to A, then taking this vector B and moving it upwards, and then joining it not to scale. Oops. And then you can also do the same going to B, and then taking vector A and adding that on to get to there. I'm already beginning to make a mess. Nope. Go over here now. Vector subtraction is probably one of the more useful. Well, okay, they're both useful, but this is very useful, as it can give you the vector between two vectors. That's an X. Scribble that out. So I'm just going to use the same two vectors for simplicity. Decrease the size of this line. So if we want to find the vector between this point A and this point B, and depending on which direction we want, we can either subtract A from B, which will give you this direction. We can subtract B from A. So this direction would be B minus A. You can visualize it as having to turn this arrow the other way around. So you're going from minus A plus B, and then the other way around is A minus B. So this gives you this vector here, depending on which direction you want. I'm going to start a new page and talk to you about unit vectors and the distance, length, or magnitude of a vector. So if I have a vector A of 3, 5, 2, then its magnitude or length, denoted by 2 bars along each side, or 1 bar, sorry, 2 bars in total, is going to equal the square root of x squared plus y squared plus z squared, or the Pythagorean theorem of evolution. And a unit vector with a little hat above it is the same as the vector divided by the magnitude of the vector, which this gives a length of 1, which is very useful, and I will show you why right now. Okay, back in the jMonkeyEngine, going to Control N, going to go to one of my templates. I'm going to call this vector math. Click enter. All this does is create some changes in the move speed and the rotation speed of the default flycam and creates a material because I get sick of having to create it all the time. So now I'm going to show you how to use vectors in jMonkeyEngine. Oh, there's a new shortcut, PR tab. Going to create a spatial. I'm going to call this S. Control Shift I. And I need to add the test data, project properties, libraries compile, and add library. Oh, where is it? There it is. So now I can use loads of assets that jME gives for me for free. Okay, first of all, I'm going to change the color of the viewport to pink because it is manly, not dark grey, pink. Color RBGA. You've never let me down before, and you never will. So now I'm going to create a new spatial using the asset manager mode model, and I hope I don't screw this up. Sinbad, and add that to the root node, and hopefully it works. No, it won't. Wow, no, not you again. It's because I need to shift F6. Yes, it's pink, but where's my model gone? Oh, I need to add a light. Where's the light? Sunlight, I drag this over. There's a little palette over there that you can steal. Control Shift I. Yes, that will do. Alt Shift F for format. Shift F6 this time. Yes! We have our ogre Sinbad! But this isn't vector math at all. I haven't done any vector math yet. Here's what I'm going to do now. I'm going to add another one. Because I can. Me lazy. I'm just going to copy and paste these two. What are you doing? I'm going to change that to S1, and don't forget to change this to S1 also. And I'm going to move it 5 units right, 5 units up. I'm not going to change the Z. Shift F6. Yes. So now these two Sinbads are at different positions. You can move around with the flycam, and you can see them in their full glory. Yes, that's fine enough. So now, what can I actually do? I can find the distance between them both, which, if I remember correctly, is I will not set get the local translation and find the distance. Yes, there is a function already there for me. S2. No, there's no S2, it's just S. And I want to system out this with S out V. I could have also just typed S out. What am I doing? Shift F6. Oh, and you can't even see it. What am I doing? Seriously? There. 7.07 units. which in jME corresponds to meters. Okay, so I've got the distance. Let's find the vector between them. Yes, I talked about that. So let me go back to this. With my trusty pen. So now, if you imagine I have a line like this. This Sinbad is at 0, 0, 0, because I didn't move him. But this one is at 5, 5, 0. So he has a vector here, and this one, I don't know how to really draw nothing, so I won't do anything. And oh, this is going to be hard to draw. For simplicity, because I don't know what else to do, I'm going to move him a little bit. Set this at 0, 1, 0. Okay, go back here. So now he's moved a little. So now he is at 0, 1, 0, and this one's at 5, 5, 0. So now I can find the vector between these two. If I want the direction to face this way, then I have to minus the first vector and add the second one. And that will get me the vector between them and the direction. So I want to minus the first one from the second one. So I'll do s1.getLocalTranslation.subtract the first one. And I will normalize this, which is the same as saying that you apply unit, that it turns it into a unit vector. So I'm going to say vector, the unit vector. No, I'm going to call this direction, because that's what I'm going to be using it as now. So that's the direction I want it to face in. And now I'm going to move the first model in the direction of the second one. And I shall do this. I'm going to first of all move this as a class attribute so that I can use it in different methods. So I'm going to take the first one, I'm going to move it. How do I do this again? I want to take the direction vector, I'm going to multiply it by time per frame. So hopefully it will work out well. Nah. Yes! Look at him go, he should exactly go over him. Yes! I shall try to explain what just happened. So he was here, the other guy was here, and our new direction is like this. It has a length of 1, so in 1 second, using time per frame, he will be at this position.